Exercise 4F, question number 8. Three events A, B, and C are such that A and B are mutually exclusive and B and C are independent. So let's start with this. We have three events A, B, and C. And events A and B are mutually exclusive. So A and B. So this is A and B, and they are mutually exclusive. B and C are independent. So let's draw the circle for C. So B and C are independent. So when events B and C are independent, then probability of B multiplied by probability of C will be equal to probability of B and C. So probability of B is given as 0.6. So 0.6. Probability of C is 0.5. And that is equal to probability of C, which is 0.3. So here we find probability of B and C, which is 0.3. Now we are given that probability of B is 0.6. Therefore, this part will be 0.3. Next, it's also given that probability of A complement intersection B complement intersection C complement is 0.1, which means outside all the three circles, probability is 0.1. Now, let's start filling in the rest of the Venn diagram. We have probability of A as 0.2. So this whole circle is 0.2. So if I write 0.2 here, so we have 0.2 plus 0.6, which is 0.8, and 1 0.9. So we need to have 1 as the total probability. So we can't write 0.2 here, which will make C as 0.5. That will be okay for C, which will make C as 0.5, which is the probability for C, and which also makes B as 0.6. But the total is not 1, because the total of any probability or the total in any Venn diagram should be 1, which means we can't keep 0.2 here. So let's try by taking 0.1 here. So since probability of A is 0.2, so 0.1 will be here. And then we need to have probability of C as 0.5, so we'll put a 0.1 here. Now if we add up all, we get 0.1 plus 1 plus 1, 3 plus 3, 6, and 9, and 1. So we get 1 total. So this is the correct filling for the Venn diagram. Now starting with B, part B1, we need to find probability of A given that C. So probability of A given that C. So this is a conditional probability, which means that we are looking at the set C only. So given that C, which means we are looking at the set C only. And from here we need to choose A. So C will be our denominator. So the whole of C is 0.1 plus 1 plus 3, which is 0.5. That's going to be our denominator, because in conditional probability, what is here, C, given that, is our denominator. And A will be our numerator. And A, out of the total of C, A is 0.1. So the answer for 1 is 0.1 divided by 0.5, which can be simplified to 1 by 5. Part 2, probability of B given that C complement. Now, given that C complement means we need to look at C complement only. So C complement is now everything outside C. So our total domain in which we are looking is outside C, which is 0.1, 0.3, and 0.1, which is 0.5. So from this, we are looking to pick up B. So B is, from all of this, B is just a 0.3. So this is going to be 0.3 divided by 0.5, which is equal to 3 by 5. And the last one, 3, probability of C given that A union B. Now given that A union B, which means we are only looking at A union B, so that's our total. So A is here and B is here. From here we are looking to pick up a C. So our total is A union B, which is 0.6 plus 0.2, which is 0.8. From there we are picking up a C, which is just 0.1. C, once again, we have A union B is our total, and from here we are looking to pick up a C. Okay, so C will be 0.1 plus 0.3, which is 0.4 out of a total of 0.8. So 0.4 divided by 0.8, which is equal to 4 by 8 or 1 by